Yeah, good morning, students. Today we'll be starting a new chapter in your statistics. So, previous chapter number 5 was analysis of univariate data. So, continuation of that one with bivariate data. So, this is analysis of bivariate data. Here in today's class, we'll be seeing of correlations. So, what is correlations? All those things we'll be seeing very detailedly for your bivariate data. So, meaning of correlation. Correlation is a statistical device which helps in analyzing the covariance of two or more variables. What here we will be seeing? Two or more variables, the covariances between those things we will be seeing here. So this correlations helps in identifying the variables. What are the covariables? Your variables are your x and y variables. With that correlations we will be identifying with correlation. Then correlations may be simple, one, multiple, or partly. So we have three covariances. One is simple covariances, other one is multi covariances, other one is partly covariances. So we will be seeing one by one here. So simple correlation concerns with a related variation between two related variables. So this is a variation, related variations between two variables. Here is your simple correlation. Then multi-correlation and partly correlation concerns with the related variables among three or more. So simple is between two, but multi and partly it is among three or more. It is more than two is your multi and partly. When the variables x and y are correlated, there may be three types of correlations. So if x and y are correlated, what are the types of relation we have? X is the cause and y is effect. So x1 will be the cause and 1 will be the effect. The other one is x is the effect and y will be the cause. So vice versa. If one is cause, the other one will be effect. Then x and y are effect of some other cases. So sometimes there will be more cases of your x and y. Both will be on the same utility. So here next example, rainfall is the causes. Rainfall is the natural causes which will be happening here, and yield of the paddy is effect. So paddy, your wheat, your ragi and all depends on your rainfall. So if rainfall is more, your effect of the paddy growth will be more. So that is your cause and effect. Then price effect and demand causes. So if prices increases, demand will fall. If prices decreases, demand will increase. So that is the price is the effect and demand is the causes. So one it changes, the other one depends on the other one. For example, onion, previous month, last month the onion price shoot up to 80 rupees. That time demand was less. What was there? Demand was less here. Then yield of a rice and tea are both effect of rainfall. So growth of the your tea, your tea is depending on your rainfall. Where it is a slope area where your tea is grown, it depends on your rainfall. Here it is a effect depends on your rainfall. Next, a cause and effect relationship between both variables is called occurrence. If both depends, we have both of the effect of variance or effect. It is not cause. If both is cause and effect, it is called as occurrence. Correlation in the absence of occurrence is called nonsense. No sense, that is no sense correlations of supervisors superiors correlated. So if it is both, your correlations is absent, there is no sense in the study of your correlations. Next we have type of correlations. One is a positive correlation, negative correlation, non-correlation and perfect correlation. So we'll see one by one. So first one is positive correlation. If a variable vary in the same direction with the correlation is said to be a positive direction. So if it is moving on a positive side, it is called as a positive correlation. For example, income and expenditure of different family. So depending on your income, the family's expenditures will vary. For higher class it is different, and for middle class people it is different. For lower class people it is different, is income and expenditure. So that is your positive correlation. Next, negative correlation. If the variables vary in the opposite direction, then the correlation is said as the negative or inverse. So here, if the in positive, if both is moving together, it is called as a positive. But in negative, if it is moving on the opposite direction, that time it is called as a negative correlation. For example, here, production and price of the vegetable. So if production is more, price of vegetable will decrease. If production is less, the price of the vegetables will increase. So it is on opposite directions. Then non-correlation. If two variables does not show the associated variation, they are said of no non-correlation. For example, sale of umbrella and sale of notebooks. So here, sale of umbrella, when it will be more, it will be more only in the during time of your rainy season. Sale of your notebooks will be more only in the time of school openings time. Rest of the time sales will be not there. So this one is your non-correlation example. Then perfect correlation. If the variables vary in the same proportion, then the correlation is said to be perfect. So if it is varying in the same, okay, everything is equal, then it is said to be a perfect correlation. The perfect positive when the variables in the same proportion and the same direction. So change of the proportion and change of the direction should be same. That is called a perfect correlation. A correlation is negative when the variables are in the same proportion but in the opposite. See here, in the positive it is proportion is same and direction is same. That is said as the positive. In negative, it is said as both in the variables in the opposite side is called a negative variation, correlation. Then we have three types of measures of correlation. So the important methods used to check whether variables are correlated or not, or one is scatter diagram, then Karl-Prass's coefficient of correlation, then Spiderman's coefficient of rank relation. So here we will be seeing problems from your Karl-Prass. Okay, from your Karl-Prass your problems will be there. Your scatter is the diagram representation that will be asked for your practical oriented question. That is for section E. Okay, 5 marks questions will be asked here. So first one, scatter diagram. Scatter diagram is a graphical representation of bivariant data to measure correlation in the scattered diagram. So here it is a graphical representation. What is a scatter? It is a graphical representation of the data, that is bivariant data. Now if the points from a line with a positive slope, the variables are perfectly and positively correlated. See the graph diagram there. Okay, my points are upward and my slope line is also upward. This is called my positively correlated. Next, if the points from a line with negative slope, the variables are negatively and perfectly correlated. See here the point, okay, of first one, it is from your 0 to 60. It is from my 0 to 60. Okay, it is upward sloping. If my curve is upward sloping, then it is said to be the positive slope. See the next one, my slope is from greater number to lowest number. That time it has been said as the negative correlation. Next, if the points crystal around a line with a positive slope with the variables are positively correlated. See the slope there. Okay, the points are here and there, but the slope is upward. Then it is a positive correlated. If the points are crystalled around a line with the negative slope, then the variables are negatively correlated. So here, see the points, okay, it is crystalled here and there around, okay, it has been mixed. But the line, okay, which is represented, it is in a downward slope. Then it is a negatively correlated. Next, if the points are spread all over the graph, the variables are non-correlated. See here, for non-correlated, the points are okay, that is my variables are here and there mixed. It is said as non-correlated. So observe the diagrams whichever I have given there and analyze it. Then Karplas's coefficient of correlation. So this is the formula where we will be using, okay, the effective of correlative measures in a figure the extra degree of correlations existing between two variables. The product momento correlated effective R. So here we will be finding R. What we will be finding R. So R is covariance of x and y divided by covariance x and covariance y. So this one, while doing the problem, I have been explained very detailedly for which problem we have to do. We have to use which formulas, okay. So first formula is your covariance of x and y divided by x variance of x and variance of y the whole root, okay. Here I have explained the differences when I am doing the problems. So tomorrow's class you will see the problems with the detailed explanation. The second formula for finding out R is correlation of your finding of second formula is the finding of x covariance of x and y divided by x standard deviation and y standard deviation. So variance of x is nothing but your standard deviation of x, okay. We can write it out both the way. So root of x variance is standard deviation of x. If standard deviation of x and y is directly given, we are not going to take the root because already that one it will be taken root. Next, the covariance finding of R. So here the next formula is the third formula is sigma x minus x bar into y minus y bar divided by sigma x minus x bar the whole square into sigma y minus y bar the whole square. So this is when bars are given, okay, your x bar and y bar values are given, you will use this formula. Next, a fourth one is finding out R. N is equal to sigma xy minus sigma x into sigma y divided by whole root of n into sigma x square minus sigma x the whole square into sigma y square minus sigma y the whole square. So in this case n and x square if they are given, we will use the fourth formula. So while doing problems I have explained very detailedly, follow the videos. Interpretation of coefficient of correlation. A positive value of R indicates positive correlative. A negative value of R indicates negative correlative, okay. Where if it is positive, it is positive correlative. If it is negative, it is a negative correlated. If R is equals to plus 1, then the correlative is perfectly positive. If R is minus 1, it is perfectly negative, okay. These are the things which have been explained previously. The same thing they are given in the points here. Then if R is 0, it is a non-correlative. Then properties of correlation correlation coefficient. The coefficient or correlation in a pure number independent of units of measurement of the variables. So it is a independent, purely it is an independent on the measures of the variables. The coefficient or correlation is not affected by the changes in the origin and scale. So when the origin and scale is changes, the coefficient will not change. The coefficient of correlation cannot be numerically greater than 1. So your R will lies between -1 and +1. The coefficient of correlation is not affected by the order. So let the order be anything, whether we have to find out xy or yx, it is not going to change anything. It will be the same. So by this I'll put an end here. So tomorrow class we will start a practical. Please write down all these slides which have been given here. This is your notes. Everything should be written on your notes. Thank you, students.